I'll show you my applets for the 4 types of conics. Okay, there are all the types of conics that are available here: parabola, circles, ellipses, and hyperbola. Okay, so first type on page 43 are the parabolas, which you should be familiar with. Things like y equals x squared. Okay, there's a sliding bar here for you to adjust. You have 2x squared, 3x squared. They all same shape, all parabola. Okay, can be negative as well. And get a second shape. Okay, then the other type is when it's sideways. This is the form x equals to ay squared. Okay, like a common one is y squared equals x, y equals to square root of plus minus square root of x. The graph looks like this. Okay, the next one is the circle, which you have learned before. Circle x squared plus y squared equals r squared. That's the general formula. Okay. Where r is the radius of circle. You can also write the equation of circle like this. Make the right side equals to 1. Okay, r squared here, radius of circle. Okay, now can I ask you what happens if the r value here and r value here are different? Okay, this a here will represent the radius in the x direction, the b is the radius in the y direction. So if these two values are different, you will get an ellipse. Okay, something like that. Okay, so in the x direction, maybe my a is 4. So the radius in the x direction is 4. The radius in the y direction is 2. So can you see these two numbers in the equation here? A squared is 4 squared, so b squared is 2 squared. So the radius are 4 and 2 respectively in the x and y direction. Okay, that is the ellipse. Okay, so you can draw this on your graphing calculator also. Okay, now I'll show you something that I can do on my applet here. You cannot do this on the graphing calculator. There's a red dot in the middle, the center of the ellipse. I can drag this around. Okay. So now the center of the ellipse may be at 4, 2. Okay, let's zoom in a little bit. You can see this 4 and 2 in the equation of the ellipse on the top right hand side. Okay, 4 and 2 are the center of the ellipse. 3 and 1 are the radius in the x and y direction. Okay, so you can see all this reflected in the equation of the ellipse. This is an ellipse. Okay, then now the last type, what happens if I change a plus to a minus? Change a plus to minus, you find that the shape is totally different. Okay, let's move this back to the center first. So for x squared minus y squared, the shape looks like this. Okay, you can see what does this, the a squared and b squared represent in a certain way. Yeah? If the hyperbola is in this shape, x squared minus y squared, the 3 here represents the distance from the hyperbola to the center of the hyperbola, 3. Okay, but the 1 has no meaning. There's nothing along the y-axis. Okay, so only 3 represents the distance from hyperbola to the center. On the other hand, if let's say the equation is y squared minus x squared, let's turn this around. Then the shape may be like this. Then now the 1 here, below the y squared, the 1 represents the distance from the hyperbola to the origin. But now the 3 has no meaning. Okay, there's nothing along the x-axis. Okay, so only one of the number has a meaning for hyperbola. So is it quite right? So your job is to identify the 2 types of hyperbola If it's y squared minus x squared is in this direction. If it's x squared minus y squared is this direction. Okay, that's all. Thank you.